Hello, AP Chemistry students. This is Mrs. Altman. We are on video number 20, Chemical Kinetics Part 2. Here are our objectives for today's video. Pause here. So oftentimes we want to determine the rate law for a particular reaction, and one of the ways we could do that is something called the method of initial rates. So what that means is that you measure the change in concentration over the change in time just at the very start of the reaction. Rates can change with time, especially for something that is not zeroth order. So that is why we only measure the initial rates. And they're measured in very, very short time periods. Pause here. Right, so I'll walk you through what this process would look like. So before really even looking at the numbers, I'm going to just write a general expression for my rate law. I've got a rate constant. I've got P4 that is being raised to some power. I'm just going to call it n. And I've got H2 that is being raised to a different power. I'm going to call it m. I don't yet know what those powers are. So now what I'm looking at is I see between trial 1 and trial 2, P4 is constant. So at constant P4 concentration, what I did, I went from 0.0075 to 0.0150. What that is that's doubling H2 concentration. And then I take a look at what happens to the rate. The rate also doubles. What that tells me is that this reaction is first order with respect to hydrogen. So I can take my expression, and now I can modify it, knowing that it's really just 1 by hydrogen. Now I'm going to determine the same thing for P4. So between trials 2 and 3, hydrogen concentration is kept constant. And in this case, it's doubling P4. And there is a negligible change. What that tells me is that this is zeroth order with respect to P4. So I can take my expression, now that I know that it's zeroth order with respect to P4. I can now make that n to the zeroth power, which is really just making it 1. So now I know that my expression is rate is equal to K times H2 concentration. Then from here, to determine the value of K, I can take any of my 3 trials. It does not matter which one I take. I'm going to take the first one. Is equal to K, and then I just take the hydrogen concentration in there. And then all I do is solve. And then the unit of time here was in seconds. This is a first order reaction, so my unit has to be 1 over seconds. So then just to put it all together, I take my rate expression. Now I know what K is. I know I can just erase this whole P4 because it's zeroth order with respect to P4. And now I can just replace that coefficient with a 1, or I don't even have to label it at all. Pause here. So now that we know mathematically what reaction order means, you're probably wondering, what does it actually mean in terms of the chemical equation? So reaction is typically going to be second, third, or more orders if the actual reaction that determines the rate, because when we look at a reaction, we're just looking at it overall. There might be intermediate steps. That's telling us how many of those have to collide with one another in order for the reaction to be successful. A reaction is typically going to be first order. If, for example, if an atom or molecule doesn't need to interact with anything else, so that would be like a decomposition reaction, or radioactivity is nearly always first order. And then a reaction could be zeroth order if it doesn't participate in a key part of the reaction. So the reaction we were just looking at, P4 probably didn't participate. Let's just say if it was a 3-part reaction and it was the second step that was the slowest, P4 just wasn't a part of that slow step. It doesn't mean that it's not important, it just doesn't affect the reaction rates. Pause here. So then there are zeroth order reactions, but then also commonly would be pseudo zeroth order. So that would just be if you have concentrations that are very, very, very high. Small changes in if a concentration is already 16 molar, the difference between 15.99 and 16 molar is so small that even if it isn't actually zeroth order, it's pseudo zeroth order because changes in the concentration of it are effectively negligible. And here are our practice problems for today's video. Thank you so much for watching and have a great night.